Hello and welcome. In this video, we will solve some example problems related to probability functions. This will help increase our understanding of the probability functions. So please watch this video till the end. In the first problem, we want to find the probability function corresponding to a random variable x, which represents the number of heads that can come up when a fair coin is tossed twice. The sample space consists of possible outcomes of this experiment, which are 4 in this case. Remember, since this is a discrete case, we can call the probability function as probability mass function or PMF. Previously, we saw that this random variable can assume values between 0, 1, and 2. Since the coin is fair, the probability of each of all possible outcomes is the same, which is 1 by 4. Now we can determine the probabilities for all possible values that the random variable can take. For example, for x is equal to 0 or x is equal to 2, there is only one possibility out of 4 in each case. So their probability is 1 by 4. However, when the probability when random variable is equal to 1 contains two possibilities, that is th and ht. And from the theorems and axioms that we reviewed previously, we can see that we need to sum the probabilities for th and ht, which results in 1 by 2. Finally, we can write the probability mass function as a table or show a bar chart or histogram to visually inspect the PMF. In problem 8, we will find the cumulative distribution function for the random variable x of problem 7, which we solved in the last slide. The cumulative distribution function or CDF for a discrete random variable can be obtained by summing its probability mass function for all values smaller or equal to x. If the random variable takes on only a finite number of values x sub 1, x sub 2, and up to x sub n, then the CDF for each interval can be found from the cumulative sum of the PMF values. In problem 7, we obtain these PMF values, and plugging these numbers into the CDF definition, we can compute the CDF for the random variable of problem 7. In problem 9, we will review a continuous random variable example. We want to find the constant c such that f of x equals c x squared for the interval when x is between 0 and 3, and f of x is equal to 0 otherwise. And we say that f of x is a probability density function. Once we find the value of c, we will then compute the probability for the random variable between 1 and 2. Let's refresh our memory and see the properties of the probability density function. There are two properties. The first one says that f of x is non-negative, and the second one says that the area under the curve is equal to 1. Since x squared is always positive, c should be greater or equal to 0 to satisfy the first property. We can integrate the probability density function, which equals 9c, but from the second property we know that the area under the curve is equal to 1 for a PDF. This gives us the value of c, which is 1 by 9. Now we can solve part B of the problem, which is to find the probability when the random variable is between 1 and 2. And after a little bit of calculation, we can see that this is 7 by 27. In problem 10, we want to find the CDF for the random variable in problem 9. Once we find the CDF, we will use CDF to find the probability when the random variable x is between 1 and 2. For the continuous random variable case, the CDF is defined by this relation. As you can see, we are essentially replacing the summation with integration. From problem 9, we know that the probability density function, and we found the value of C, which was 1 by 9. Now we need to find the CDF values in three intervals: x is less than 0, where f of x is 0 as PDF values are 0. Then we want to find the value when x is between the interval 0 and 3. In this case, we can solve this integral and we can see that the CDF value in this interval will be x cubed divided by 27. And finally, the last interval, that any value greater or equal to 3. And since it is a cumulative distribution and PDF only contains all values in the interval between 0 and 3, so the integration over this interval is already equal to 1, which will remain 1 for all values of x greater than or equal to 3. This gives us our CDF for this problem. Now to solve the part B, since we already know that we are trying to find the area under the curve, which is equal to the difference between the area to the left of x is equal to 2 and area to the left of x is equal to 1, which are essentially the differences between CDF values when x equals 2 and 1. And we already know that all we need to do is to plug 2 and 1 in x cubed divided by 27. That gives us the result, which is 7 by 27, which, if you recall, is the same as we obtained in the previous slide. Okay, I hope you have gained a better understanding of probability functions through these examples. Please press the like button and share this video, and if you haven't subscribed to my channel, please do so to get updates on the latest videos. In the next video, we will review joint distributions. Thanks for watching and see you all in the next video.